The universe has always been a realm of countless wonders, from colossal supergiants and hellish exoplanets to ravenous black holes and enigmatic signals from the void. It captivates us in a profound way, driving humanity to explore and conquer its deepest secrets. Today, with the remarkable advances in science and technology, many of the universe's darkest mysteries have been brought to light, revealing the astonishing diversity of distant worlds. Recently, scientists detected a truly peculiar object in the cosmos, a brown dwarf. It is neither a true star nor an ordinary planet, but something caught in between. But this newly discovered brown dwarf holds an even greater surprise. Its surface burns hotter than our own sun, a phenomenon never before witnessed. What could possibly explain this? Join us as we investigate. Brown dwarfs are mysterious, little understood objects. They are not quite stars, nor are they planets, but celestial bodies occupying the shadowy gap between the two. Often called failed stars, they lack the mass to sustain nuclear fusion in their cores like true stars, yet they are far more massive than any planet. Since their first discovery in 1995, hundreds of brown dwarfs have been identified, slowly unveiling the secrets of these strange, hybrid objects. But the latest find is unlike any brown dwarf we've ever seen. Catalogued as WDOO32317b, it lies about 1,400 light-years from Earth, and it defies all expectations. While typical brown dwarfs are relatively cool, around 2,200 degrees Celsius, this one is an inferno. Its surface temperature soars to 8,000 Kelvin, roughly 7,727 degrees Celsius, over 3 times hotter than normal. Even more astonishingly, that temperature exceeds the surface of our Sun by more than 2,200 degrees. For a brown dwarf, this should be impossible. The discovery left scientists baffled. Measurements were double-checked, yet the data held firm. There was no mistake. The brown dwarf was genuinely, inexplicably scorching. So the question became, how could the universe produce such a searing, failed star? The answer began to emerge when researchers looked closer. WDOO32317b was not alone, it had a companion, a white dwarf. The brown dwarf orbits this white dwarf at breakneck speed, completing a full revolution in just 2.3 hours. This revealed an extremely tight, blisteringly fast orbit. White dwarfs are the dense, glowing cores of dead low to medium mass stars. After a star sheds its outer layers, the remaining core collapses into a white dwarf, initially blazing at hundreds of thousands of degrees before slowly cooling over eons. Scientists realized the brown dwarf's proximity to this searing remnant was key. But the full explanation was even stranger. The intense gravitational pull from the white dwarf doesn't just heat the brown dwarf, it locks it in a deadly embrace. One side perpetually faces its brilliant companion, while the other faces the cold void of space. This creates the most extreme temperature dichotomy ever observed on a substellar object. The day side, bombarded by radiation, reaches those staggering 8,000 Kelvin. The night side? A comparatively frigid 1,000 to 2,700 degrees Celsius, a difference of over 5,000 degrees. The contrast is so severe that molecules on the hot side are being torn apart, vaporized by the relentless heat. This brutal environment suggests the brown dwarf may not survive long in this cosmic furnace, its fate sealed by an orbit that both illuminates and destroys. Not only is VKFD00323317b the hottest brown dwarf ever recorded, it is also one of the most massive ever discovered. Typically, brown dwarfs have masses ranging from 13 to 80 times that of Jupiter, the largest planet in our solar system. But this newly discovered cosmic anomaly boasts a staggering mass, approximately 88 times that of Jupiter, placing it far beyond the known upper limit for ordinary brown dwarfs. This makes it, to our current knowledge, the single most massive brown dwarf in the observable universe. It is no exaggeration to say this object ranks among the most bizarre celestial bodies ever found. Even seasoned astronomers are left grappling with the profound mysteries it presents. The existence of brown dwarfs was first theorized in the 1960s, yet for decades, all searches for them came up empty. It wasn't until 1995, over 35 years later, that the first brown dwarf was finally confirmed. That object, named Theta 1, lies in the direction of the Pleiades star cluster, roughly 400 light-years from Earth. Scientists believe brown dwarfs form in a similar way to regular stars. They are born from the contraction and collapse of a giant molecular cloud. However, if the collapsing protostar has an initial mass less than 0.08 times that of our Sun, the critical temperature for hydrogen fusion is never reached. The core simply does not get hot enough to ignite sustained nuclear fusion, resulting in the birth of a brown dwarf. In essence, a brown dwarf is a failed star, an object without sufficient mass to light the nuclear furnace at its heart. It exists in a strange limbo, caught between the most massive gas giant planets and the least massive true stars. Beyond being called failed stars, brown dwarfs are also described as planet-like, possessing complex outer atmospheres riddled with colossal, swirling gas clouds. Their structure bears a striking resemblance to gas giant planets. The International Astronomical Union, IAU, currently defines a brown dwarf as an object with a mass at least 13 times greater than Jupiter's, yet without sustained nuclear fusion in its core. An object below this mass threshold, in orbit around a star or stellar remnant, is classified as a planet. Despite the name brown dwarf, these objects are rarely brown. Their apparent color is a phantom, a trick of the light, dictated entirely by their surface temperature and the visible spectra it produces. For instance, a newly discovered star, due to its extreme heat, will often glow with an orange or red hue. In contrast, cooler brown dwarfs may appear a deep crimson or even seem nearly black. Once a brown dwarf forms, the remaining material from its parent molecular cloud coalesces into a protoplanetary disk encircling it. These disks are typically limited in mass, meaning the planets that form around brown dwarfs are more likely to be rocky, terrestrial worlds rather than gas giants. The potential habitability of such planets is under investigation, though most models suggest the chances for life on terrestrial worlds orbiting brown dwarfs are exceedingly slim. A lingering debate persists. Do brown dwarfs, at any stage, truly experience sustained nuclear fusion? While this remains an open question, it is confirmed that brown dwarfs can fuse deuterium, and the most massive among them can also fuse lithium. We can hope that in the near future, new research will unveil the secrets of these cosmic underachievers, the failed stars we call brown dwarfs. Thank you for joining us. We hope you found this journey both fascinating and enlightening. Until next time, stay curious. Goodbye.